Okay, I'm going to look at this problem of finding the distance from a point, which I've given here, 7 minus 5, 4, distance from that point to this plane. And I'm going to look at two methods. The first method, I'm going to think about finding a line that goes directly to the plane. I'm going to call this point P here. I'm going to call this line 1. And I can find the equation of line 1 really easily because I know a point, 7 minus 5, 4, and because it's perpendicular to the plane, I know its direction is 2 minus 2, 1. So with a line and a plane now, I can easily find P. So let's just say to find P, intersect the line L1 and the plane. And we can do this, we've done this before. I know that the plane, I like the r dot n form, r dot 2 minus 2, 1 is 10. So I'm going to substitute that line into this plane. So I'm going to have 7 plus 2 lambda, minus 5 minus 2 lambda, and 4 plus lambda. That's the r. I'm going to dot that with the normal vector, 2 minus 2, 1. And to intersect that plane, that needs to equal to 10. So I can solve this. Let's go about this. This gives me 14 plus 4 lambda plus 10 plus 4 lambda plus 4 plus lambda is 10. I'll leave you to solve that through. That comes out to be lambda turns out to be minus 2. Now what that enables me to do, I can now put lambda is minus 2 into this equation to find the point P. So I can say therefore O to P must be 7 minus 5, 4. I'm looking at this equation up here, minus 2 lots of 2 minus 2, 1, which turns out to be 7 minus 4 is 3, minus 5 plus 4 is 1, minus 1, and 4 minus 2 is 2. So I've got the point P. I know A, I know P. Remember the distance that I'm actually after is this distance here. So I can now find the vector AP and find out how long it is. So my last steps, I say, well, okay, A to P must be this vector, 3 minus 1, 2, minus the position vector of A, which I know is 7 minus 5, 4. So I can find out that AP is 4, so minus 4, 4 and minus 2. And then I can finish this off. So therefore, distance from A to the plane is equal to the length of the vector AP, which I can now work out is going to be the square root of 16 plus 16 plus 4. Turns out to be, what's that? That's root 36, which is 6. So I've solved it. And the geometry of that is quite nice. You find the coordinates of what's sometimes called the foot of the perpendicular, find that vector A to P, and then find its length. Okay, so that works perfectly. I do, though, want to show you this other method as well. Might be a little bit shorter. You might prefer this one, you might prefer the first one, but I want to show you. And the slight difference here is that rather than finding the point P, I'm just going to find any old point on the plane, and I'm going to find this vector A to Q, and I'm going to project that vector onto the normal, because I know that if I do that, the shadow that will be cast, the projection will equal the distance that I'm after. So the first step here is just to find any point on the plane. I'm going to call that Q. And I can then pick any values of x, y, and z as long as it makes this true. So I'm going to pick x is 1. I'm going to pick y is 1. And I'm going to figure out what z needs to be. So I'm going to have, therefore, 2 lots of 1 minus 2 lots of 1 plus z must be 10. Z must be 10. So therefore, Q with the coordinates 1, 1, 10 lies on the plane. Okay, so I've got that. That's relatively easy to do. So therefore, I can now find, therefore, vector A to Q is going to be 1, 1, 10 minus 7 minus 5, 4. So I can find A to Q is 1 minus 7 is minus 6. 10, so 1 plus 5 is 6. And 10 minus 4 is also 6. So I've got the vector AQ, and all that I need to do now is project AQ onto the normal vector. And I can do my projection, so let me just jot this down. Project AQ onto the normal vector. And what I do there, I know that this is minus 6, 6, 6, dotted with the vector you're projecting onto, 2 minus 2, 1, divided by the length of the vector you're projecting onto. So the length of n, which is going to be square root of 4 plus 4 plus 1. And now I can figure this out. Hopefully I get the same answer as before. What have I got here? I've got minus 12. I've got another minus 12. And I've got plus 6 divided by root 9, which is 3. What does this turn out to be? That's minus 18 over 3, which is minus 6. And of course, remember, the distance is going to be the absolute value of that. So from there, I can finish off by saying, therefore, distance of A from the plane is equal to 6, just as I had before. So a slightly different approach, using the idea of a projection, and you can see it gives us the same answer again. So useful to have both techniques at your disposal, and if you're just asked to do that question, then you can use whichever method you prefer.